Hello everyone. On this video we will be looking at comparing fractions, and to do that we will start with finding the least common denominator. Okay, now first, to do that we have to learn how to find the least common multiple. Okay, the least common multiple, you'll usually see that as LCM. Okay, and the least common multiple is the smallest multiple that two or more numbers have in common. All right, so for example, what if we wanted to find the least common multiple of 3 and 7? All right, so how do we do that? Well, we start off by finding the multiples of 3. Okay, so we know the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, and it keeps on going and going and going. How do we know these are the multiples? Because this is 3 times 1, and this is 3 times 2, and this is 3 times 3, and this is 3 times 4, and this is 3 times 5, and etc., and so on. So those are your multiples. Oops, if I can clear this up a little. That's a little bit better. Then we find our multiples of 7. And that's 7, 14, 21, 28, 35, 42, and it keeps on going and going and going. Okay, so that means this is our 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, and etc. and so on. Now, when we go to our multiples of 3 and our multiples of 7, what's the smallest multiple that they have in common? You don't have a 7 up here. You don't have a 14 up here. But you do have a 21. That's the smallest multiple that they have in common. So that means the least common multiple of 3 and 7 is 21. Might as well circle that. All right. So let's go ahead and move this up a little bit. Okay, so for example, let's say we want to find the least common multiple of 4 and 12. All right, and what I want you to do is go ahead and press pause and try to do this one on your own using that method up there. All right, so I'm assuming you've gone ahead and pressed pause and you've worked this one out. So let's go ahead and verify your answer. Okay, first we find our multiples of 4. Multiples of 4, which is 4, 8, 12, 16, 20, 24, 28, and etc. And then you have your multiples of 12, which is 12, 24, 36, 48, 60, 72, and so on and so on and so on. Okay, so if you look at all of your multiples, the smallest that they have in common, that would be the 12. So that means the least common multiple of 4 and 12 is 12. That's the smallest multiple that they have in common. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our steps for comparing fractions. All right, so for comparing fractions, these are the steps. And again, if you have steps that work better for you, by all means, feel free to use them. These are just some steps to get you going and until you come up with your own process. Okay, first, you want to find the least common multiple of the denominators, which is called the least common denominator. You'll see it as LCD most of the time. Okay, second, you want to convert each fraction to an equivalent fraction where both of the denominators are the same. Okay, and by an equivalent fraction, remember how we had 1/2 is equal to 2/4 is equal to 4/8 is equal to 8/16. So those are all equivalent fractions. They have the same value, we just wrote them down in a different way. Okay, number 3, once the denominators match, then you're going to compare your numerators. Okay, so the fraction with the largest numerator is the largest number. Okay, so that's only after you get the denominators to be the same, you compare your numerators, and you have your equivalent fractions. All right, so if you're still writing this, by all means, feel free to press pause and finish writing it all down. But we're going to go ahead and move on to our first example of comparing fractions. Okay, so for example, what if we wanted to know which is larger? Seven eighths or 5/6? Okay, so your first step is you're going to find the least common denominator, which is the least common multiple of your denominators. Okay, so your first step is you're going to find the least common multiple of your denominators 8 and 6. Okay. So again, after you do these for a while, you'll be able to kind of look at them and do them in your head. But if you're not at the point where you can do them in your head yet, you can always do this method. So you have your multiples of 8. Remember, 8 times 1, 8 times 2, 8 times 3, 40, 48, and that should be enough. Okay, so you have your multiple of 6, which is 6, 12, 18, 24, 30, 36, etc., and so on. Remember, that's just 8 times 1, 8 times 2, 8 times 3, 8 times 4, 6 times 1, 6 times 2, 6 times 3, 6 times 4, and it keeps on going. So those are just your multiples. Okay, so we see here that the lowest multiple that they have in common is 24. Okay, that's the smallest value that they have in common. Okay, so we know that's your least common multiple. We know 24 is 8 times 3, and multiples of 6 is 6 times 4. All right, so now your second step, you're now going to rewrite both of those, 7 over 8, and put a little space there, and you have 5 over 6. Okay, so what we're going to do is we're going to now get both of these fractions to where your denominator is 24. Okay, so how do we turn 8 into 24? We multiply it by 3. So that means we're going to multiply this by 3 over 3, because anything you do at the denominator, you have to do it at the numerator. And how do we turn 6 into 24? We multiply by 4. So we multiply this by 4 over 4. Okay, so now we just go ahead and multiply it across. So 3 times 7 is 21. Over 3 times 8, which is 24. 5 times 4 is 20. And 6 times 4 is 24. So we have our equivalent fractions. Just in case you're wondering how we went from here to here, remember, 7 over 8 is equal to 21 over 24. Those are equivalent fractions. And 5 over 6 is equal to 20 over 24. And if you go ahead and rewrite these in lowest terms, you'll see you'll end up right back here. So if you simplify this 21 over 24 to lowest terms, you'll end up with 7 over 8. If you simplify 20 over 24 to lowest terms, you end up right back at 5, 6. Right? So once we have our matching denominators, we compare our numerators, and we can see here that 21 is the larger numerator. Okay, since 21 is the larger numerator, that means 7 over 8 is larger than 5, 6. So 7 over 8 is larger than 5, 6. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Excuse me. Okay, so which is larger, 3/5 or 4/7? All right, so remember, actually, before I start on this, I want you to go ahead and give it a try. So go ahead and press pause and try to do this one on your own. All right, so I'm assuming you've pressed pause and you've tried to solve this one on your own. So let's go ahead and verify your answer. So remember your first step is to find your least common denominator. or the least common multiple of your denominators. And remember, if you can't do it just by looking at it yet, you'll get there with practice. You'll be able to just go ahead and multiply it in your head and figure it out. But if you're not there yet, you have your multiples of 5. Just 5, 10, 15, 20, 25, 30, 35, 40, and it keeps on going. Then you have your multiples of 7. Just 7, 14, 21, 28, 35, 42, 49, and it keeps on going. Okay. Now, what's the smallest that they have in multiple they have in common? Well, that would be 35. 35 multiples of 5. 5 times 7. And for multiples of 7, it's 7 times 5. All right, so now we get our fractions. We have 3 over 5. And we have 4 over 7. Let me move this over just a little bit. All right, so now we want to turn 3 over 5. We want that 5 to have a denominator of 35, and we want this 4 over 7 to have a denominator of 35. So how do we turn 5 into 35? 5 times 7. So anything we do with the denominator, we have to do it to the numerator. And how do we turn this 7 into 35? 7 times 5. So we make that 5 over 5. And then we just multiply it across. 7 times 3 is 21. Over 7 times 5, which is 35. You have 4 times 5, which is 20. Over 7 times 5, which is 35. All right, so if you notice, once again, this is the larger numerator. And since we know that 3 over 5 is equal to 21 over 35, and 4 over 7 is equal to 20 over 35, they're just equivalent fractions. We know that 3 over 5 is larger than 4/7. All right, now, it's one thing I want you to notice, and I'm going to go back to the previous problem just for a second. Okay, so if you notice, here the 7 is larger than the 5, and this 7/8 happen to be the larger number. Let me move this up a little. Okay, so this 7 is larger than that 5, and this 7/8 is a larger number. Here, this 4 is larger than that 3, and the 3/5 ended up being the larger number. So which number is larger, has a larger numerator before you get matching denominators or like denominators? Doesn't tell you a thing. So you can't say, oh, okay, 3/5 and 4/7. This 4 is larger than this 3, so this is going to be the larger value. You can't tell that just by looking at it until you get the same denominator. Once you get the same denominator, then you compare your numerators. Because if you compare your numerators here, and you pick the 4 over 7, you would have been wrong. So you always want to make sure you have your like denominators before you compare your fractions. All right, so if you are still writing, feel free to press pause. But we're going to go ahead and go to our next example. Okay, so which is larger? 3 1/2 or 2 7/4? Okay, now I want you to go ahead and solve this one. I'll give you a hint. You want to, when you have a mixed number and you want to find out which one is largest, you want to convert both to improper fractions. Before starting your steps. All right, so I want you to go ahead and press pause, and I want you to try and do this one on your own. All right, so I'm assuming you've pressed pause and you worked through it and you have the right answer. So let's go ahead and just verify your answer. Okay, so you have 3 1/2 and 2 7/4. Okay, so we're going to go ahead and convert them to improper fractions. And if you don't remember how to do that, just go ahead and go back to the improper fractions video. So you have 2 times 3, which is 6, plus 1, which is 7. So you have 7 over 2. And you have 4 times 2, which is 8, plus 7, which is 15. You have 15 over 4. Okay, so we have 7 over 2 and 15 over 4. Now we can go ahead and compare those fractions. So we find our least common denominator, which means we have to find our multiple of 2. 2, 4, 6, 8, 10, etc. And your multiple of 4 is 4, 8, 12, 16, and it keeps on going. And the smallest multiple they have in common is 4. Okay, so this, by multiples of 2, 4 is just 2 times 2. And for our multiples of 4, this 4 is 4 times 1. Because remember, our multiples is 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 4 times 1, 4 times 2, 4 times 3, 4 times 4, etc. All right, so that means we have to turn this into 4, which is already 4, so we're good there. And we also have to turn this into 4. And we turn this into 4 by multiplying by 2, because you know that 2 times 2 is 4. So anything you do to the numerator, you have to do to the, well, anything you do to the denominator, you have to do to the numerator. So if we multiply the denominator by 2, we have to do the same to the numerator. So we have 2 times 7, which is 14, over 2 times 2, which is 4. And we have 15, since that was already 4, we didn't have to multiply this one by anything. So we still have 15 over 4. So now we compare our numerators. And we see here, let me kind of box this off a little bit. This is the larger of the two numerators. All right, so we have to remember that 3 1/2 is equal to 7 over 2, which is also equal to 14 over 4. And 2 7/4 is equal to 15 over 4, because we converted it to an improper fraction. And that's just still 15 over 4 because we didn't have to change the denominator any. All right, so since 15 over 4 is largest, that means 2 7/4 is larger than 3 1/2. All right, so once again, don't be fooled, because you may look at that and go, okay, 3 is bigger than that one. No, 2 7/4 is actually larger. All right, so hopefully this made sense, and I will see you on the next video.